All right. When you're doing rationals, you're probably going to see a problem that says something along the lines of state any restrictions on the denominator. So imagine you had this problem. When you see this, you have to kind of think to yourself, what could X not be? Like if it was a certain number, would we get a problem? Would we have an error kind of thing? So if you look here, if X was 3, you would get 2x plus 7 over 0. That is undefined. That's where you're going to get an error. So in this scenario, X cannot be 3. And so basically all you have to do is just take whatever, you factor it first, but take whatever factor is there and just set that equal to 0 and go solve. You'll get X equals 3, but it's really what it cannot be. So that's all you have to do for that. Let me show you a couple more. What if it was like, what if it was like this one? You want to factor it fully first. And then before you cancel anything or do anything, like, yeah, I know these binomials are going to cancel. Super easy, right? Well, before you cancel or simplify, take each of these and set them both equal to 0 and solve. And you're getting like x equals, but it's really what it cannot equal. So these would be the restrictions there. Okay, one more, just the most common mistake one. I'm already going to factor it, so. Okay, of course, right here, x cannot equal 4. Cool. But this guy is also important, and he's the most missed. You still have to set him equal to 0. So it could not be 0. Because if it was 0, the whole denominator would be 0, and then you would get an undefined. So that's how you find the restrictions on a rational function. And by the way, just so you know, when you're getting these restrictions, they're either holes in the graph or they're vertical asymptotes. So the function is undefined at those locations. So those are restrictions. Hope this video helped.